Okay, give IUPAC names for the following compounds. So let's see. I don't really like the sort of condensed structure here, so I'm gonna draw this out in a way that looks easier for me to that's a skeletal structure, which is what I'm used to. So this is A, and so the first thing to do is find the longest carbon chain. So that would be this one. And then number the carbons. So we'll number it giving the first substituent. So this is the substituent here, the lowest number. So 1, 2, 3, 4, 5. So this one is going to be 2-methyl pentane, and it's one word, so 2-methyl pentane. So let's look at B. So B is this compound here, where you have 2 methyls attached to this carbon here, and a 4-carbon chain, and let's just draw the chain here. The longest carbon chain is this one, and we'll number it so that the substituents, these 2 methyls, get the lowest numbers, so that would be numbering from here, 1, 2, 3, 4. And so this compound will be 2,2-dimethyl butane. Okay, C. Gosh, these condensed structures are just terrible. Okay, so we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we have 2 methyls on the 3rd carbon here. All right, so let's look at this one. The longest carbon chain here is this linear chain. It's not always going to be like that, but in this case it is. So we'll number giving the first substituent the lowest number here, this methyl here. So we'll start on this end, 1, 2, 3, 4, 5, 6. And so we have a methyl on 2 and then 2 methyls on carbon 3. So this would be, this compound is 2, 3, 3 trimethyl hexane. It's a hexane because it has a 6-carbon chain. Okay, let's look at D. So D here, getting back to blue. So I'm just going to count these, 1, 2, 3, 4, 5, 6, 7. So I'm going to draw a 7-carbon chain, and we have a methyl on this carbon here, and an ethyl, 1, 2, on this carbon, methyl coming off there. So what is the longest chain? Well, you can draw a circle around it. This is the longest chain here. And I will number the carbons. So we'll give the first substituent the lowest number, and that would be this methyl here. So if we number 1, 2, 3, 4, 5, 6, 7, and there's a methyl on 2 and an ethyl on 5. But ethyl comes before methyl alphabetically, so we name the compound with the ethyl first. So 5-ethyl, 2-methyl heptane. 5-ethyl 2-methyl heptane. Okay, so moving along to E. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to draw this 8-carbon chain here. And I'll just draw it the way we have it here. 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8. And then we have a methyl on this one, and a methyl there, and then a methyl on this carbon here. Okay, so as I numbered it, I could already tell in this picture here with the condensed structure that this is the longest chain right here. So that would be this chain here. That's our carbon chain. And we'll number it. So we'll number it beginning on this end to give these two methyls the lowest number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think I got one too many. 1, 2, 3, 4, 5, 6, 7, 8. Oops, I have too many carbons, and it looks like it's on this end over here. So actually I put too many carbons here. I'll just guess that's what I get for trying to convert the condensed structures into skeletal structures, but oh well, at least I caught it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it looks like we have 2 methyls on the 3 carbon and 1 methyl on the 5 carbon. So this will be 3, 3, 5 trimethyl octane. 3,3,5 trimethyl octane. And let's go to F here. So F has, let's see, we'll say a methyl there, another methyl coming off, and 2 methyls here, and then a 3 carbon chain, 1, 2, 3. Let's see, now I'm going to count my carbons this time. So we have 1, 2, 3, 4, 5, 6 in that chain. So 1, 2, 3, 4, 5, 6. And then 2 methyls here and 2 methyls there. So if I circle the longest carbon chain, it would be right here. And that will be a hexane. And then numbering it, so 1, 2, to give the first substituent, these 2 methyls, the lowest number, 3, 4, 5, 6. So this is going to be 2, 2, 3, 3 tetramethyl. So there's 4 methyls here. So 2, 2, 2, 3, 3 tetramethyl hexane. 2, 2, 3, 3 tetramethyl hexane.